Hello, folks. Hope you're doing well. Um, Anybody got anything that they would like to say this evening before we get going? Okay, I'm checking people into their groups while they're getting in here. So, okay. Anybody got a question about? Oh, I should make sure you can hear me. Let's do that. Let's see. Uh, okay, there we go. Let me know if you cannot hear me, please. Okay, looks like we're good there. Let's go. Let's take a look at Blackboard for a second, and then we'll get on doing the lab. Oops, a little bit too quick. Oh, there we go. Okay. So anyway, excuse me. Um, yeah, I think last time we were talking about the research thing, and I was saying we couldn't come up with anything, or couldn't come up with an idea that would work. But then what I was thinking about is the way the class went last fall. We had one more lab, and so when I was organizing for this spring, I dropped a lab and put in the research project. So what I'd like to do is just go back and put a lab report back in. So there'll be one more lab after tonight, but there will not be a research project. So a couple more things here on the announcements. Don't forget about our peer mentor if you need some help. He's running sessions. Be sure you do what he said in his email, not what I have up here on this announcement. It might not be right. Today I got a thing about places for Wi-Fi hotspots. So if you click on that link, or you probably have to paste it in, but anyway, if you go to the link up there where it says Wi-Fi hotspots, it'll help you find things, hopefully in your area if you're having trouble getting a decent internet connection. So, of course, it won't if you can't get out or some other things going on. But anyway, might help some people. Okay. Next thing is going to be sapling. The thermodynamics is due tonight. We finished that up and started on the electrochem, so you guys should be okay to do this. Probably these electrochemistry assignments will get moved some because we won't be ready for those. So anyway, that's all that stuff. Anybody got a question or anything before we go to the lab? Okay, I'm not seeing anything, so I guess we'll go ahead and get on with the lab. Um, so as usual, to get to your lab, you go to Blackboard course materials and scroll down to where it says lab report. And then if you click on that, you'll see the lab report that you still need to return a report in for. That's the voltaic cells one. And then you've got the one for the new lab we're doing tonight. So the one we're doing tonight is qualitative analysis simulation. We used to do this as an experiment in class, but it a lot of time, so we stopped doing that. And one of the reasons why it took so much time is that we were analyzing for more than just three metal cations. Um, but tonight we're just going to be doing these three, and of course we're not doing a live experiment anyway. So what it's saying here, follow the instructions on the attached file. We'll look at that in a second. There's a link to the simulation. Um, And then it says produce a lab report with these items and the usual stuff. Title, date, partners. There is an unknown for this lab, and the simulation assigns you that unknown randomly. So whenever you go to do it, it will give you your unknown number. Be sure that you write that number down and be sure you put in your report. And depending on how you're doing this as a group, when you get to this part, you definitely need to all be looking at the same simulation. So somebody needs to be running the simulation and everyone watching or something like that. Now the other parts you guys could split up and then just share your results. So, but for the last part there where it says assigned unknown, you all need to be doing the same one because you need a single unknown, not, you know, 2 or 3. Then after unknown number, you got 3 discussion questions. Those would be taken from the 3 experiments, trial 1, trial 2, trial 3. And what you're doing is, how would you identify silver but exclude lead or mercury? And then how would you identify mercury but exclude silver and lead, and so on. So anyway, you need to come up with a brief statement as to how you do that. Then data table comes from experiment 4, and that one's called trial unknown, and everyone will be doing the same one. So when I'll show you where these are at on the simulation, but you know, you all will be doing the same one, so you'll be getting the same result for it. And so you'll have a data table. That's where you're recording your observations as you're doing the different tests to identify what it is. And then the results would be what ions are present. And when you're following the instructions, it'll tell you that when you're doing this one, that you'll need to do a screenshot of the simulation whenever you mark up what is the unknowns. And then the last experiment, trial 5, that's when you got the unknown, an assigned unknown. It's randomly picked. You'll have a table of your results of your observations, and then you will decide what ions are present in your particular sample. So it could be, you know, lead and mercury, or just some combination. There's a whole bunch of different combinations possible. Then you'll have comments, and then these would be 2 files. One would be a screenshot of when you do the trial unknown. That's the one that everyone's will be the same. And then you need a PDF of the report from your assigned unknown. So now I'm going to go to the instructions for doing this. So here we go. In this simulation, you'll analyze a mixture of metal cations, that's the silver, mercury, and lead, to determine which are present. This analysis is an application of selective precipitation of ions, which was in chapter 15, equilibrium of other reactions. The simulation is found at this URL, so we'll click on that in just a moment. You may need to allow Flash on your browser for this web application to work. This depends on what your security settings are on your browser. And then on opening, click on discussion. It's in the top middle of the page. It'll explain all the reactions that are used for the analysis of silver, mercury, and lead. Next, be sure you click on flow sheets, and it'll give you an organized approach to using those reactions to do the analysis so that you're not just randomly doing stuff. If the operating instructions are not shown on the bottom right, click on operations. It should default to show those, but if not, you just click on where it says operating instructions. It'll tell you how to operate the simulation. However, there's one thing that's not really clear. That's why I got here. One aspect of simulation may not be clear. That is if you're testing pH. So test the pH of a solution. You select the test tube by clicking on it, and you'll get a red arrow pointing at the test tube. Then towards the top of the page, you click on a stir rod. and then it'll go into the test tube, and then it'll put a drop of the solution onto red litmus paper, and it'll put a drop on the blue litmus paper. And if you get a blue spot on red paper, the solution is basic. And if you get a red spot on blue paper, it's acidic. Then it goes to about the trials 1, 2, and 3. You're going to pick silver from the samples drop down, and then you complete the steps to identify it as silver. And then you do that again for mercury, and then you do it for lead. Then you do it for the trial unknown, which is a mixture. And for that one, follow the flow sheets as to the order to do things, because that will be your quickest way to get that done. And then for trial 5, select assigned unknowns from the sample drop-down menu. And a window will open with your assigned unknown. It'll be some number between 101 and 99, or 999. Be sure you write that number down and include it in your report. Let's see, complete the steps found in the flow sheets to identify silver, mercury, and or lead. Check unknowns, and you need to complete that, which you're going to be selecting which ions that your group has decided is in your unknown mixture. Then you click on a button that says prepare to print, and then it'll pop up a window that you can put your names on. You click OK. You may need to allow pop-ups on your browser. It'll sort of know if it's not working. And then you should get a report. You get this window as a report. You save that report as a PDF to include with your report, your lab report, the big report. I got a couple notes here as far as how to do screenshots. If you're using an Apple, then you go to your applications and pick the application called Screenshot, and you'll figure that out pretty quick as to how to use it. If you're using a PC, then there is a key that's in the upper right-hand side of the keyboard, and it's going to say PRT-SCRN. If you push that key, it makes a copy of whatever is on your screen, and it goes to the clipboard. So, if you've been fooling around with PCs for a while, you know that having something in the clipboard, you still can't print it or save it or anything. So what you need to do then is open up Paint. It's a Windows application that comes with Windows. And then you paste in from your clipboard. So now whatever was on your screen will be in Paint. And now you've got something that you can make a file from. So you save it as a file, as a Paint file, and then attach that to your lab report. Actually, don't put it in as a Paint file. It needs to get saved as a PDF. Okay. So anyway, that's the instructions. Let's see what the simulation looks like. So you can click on the URL here or what's back at Blackboard, same thing, and this will appear. So like I said, the operating instructions are over on the right side. These 4 in the middle, these are all links, so you can click on discussion. This talks about the reactions that you're using. If you click on the next one, you're going to get a flow chart of how to do the experiment. So it just means that you start out with your unknown, and then you do the steps. Add 1 to 2 drops of hydrochloric acid, 3 molar. Centrifuge your sample, decant your sample. When you decant, you'll separate the solid from the liquid. Then you take the liquid and you really can't do anything else with it, so you discard it. But your solid, it may contain silver, mercury, or lead. So you need to add 2 drops of distilled water, heat, and so on. And you guys can read this thing, so I'm not going to keep going there. Then you don't click on check unknown until you're ready to check on your unknown. So I'm going to go up here under samples and pick a sample to work on, and I'm just going to do silver. Okay, Now, when I did that, the bottle below that, the label changed. Now it says silver standard. And if I want to put some of that silver solution into a couple of test tubes, I pick the test tube I want to add it to. So I click it. You get a red arrow below the test tube. Then you click on the bottle, and the dropper will appear above the test tube. If you click it, it'll put a drop in. If you click it again, you'll get another drop. If you click it again, you can get 3 drops. Now, if I want to then put it in that second test tube, I can just go below the test tube and click on it. Oh, not below, excuse me. Click on the test tube, and I'll get an arrow below, and the dropper will move over, and then I can put 3 drops in it. So 1, 2, 3. And then if I want to put some in the third test tube, I can do that. And so now I've put some of the silver solution into 3 test tubes. To put the dropper back in the bottle, you click on the bottle. Now I want to do a reaction to show that it's silver. So I could react it with hydrochloric acid, and that would make silver chloride, which is a precipitate. So I click on hydrochloric acid. I click back on the first test tube. I click on the bottle of hydrochloric acid. The dropper appears above the test tube. You guys are getting this. I click it one time, and I get a precipitate. You can see how you get this white stuff in there. Let's say I want to do the same thing to the next test tube. I can click on it. It should do the same thing. I'll put the dropper back in the bottle. Now there's some other reagents that I have to work with up here. I got nitric acid, potassium hydroxide, ammonia, sodium chromate, distilled water, different things. Now, if I wanted to check the pH of the first test tube, I'd click on it, and the stir rod is this up above here. You can see there's the red strip of red litmus paper, the blue strip of the blue litmus paper, and the stir rod. So if I click on the stir rod, it's going to go to that first test tube. It's going to put a drop on each of the litmus papers. And if I do that again, because that happened pretty fast, you see the blue paper has a red spot. So that means the first solution is acidic. If I go over here to just the silver solution, I don't really know what will happen, but let's see what happens with that. It's not quite as red, but it still thinks it's acidic. So now if I wanted to centrifuge this to put all of the precipitate at the bottom of the test tube, I could click on centrifuge, and you get this little animation here, your centrifuge spinning. And now you see the precipitates at the bottom of the test tube, and there's a liquid above. Now if I want to take the liquid that's above and put it in one of these other test tubes, I can select the tube I want to take the liquid from, and then I click on decant. That means, pouring off a liquid without disturbing a solid. So it does that. You see it sucked the liquid up into the dropper. All you have left is the solid. If I want to transfer it over to this fourth test tube, I just click on, oops, yeah, well, it did it without me clicking it. Anyway. So now I've got stuff in all these different test tubes, and I can do more things to them. I can heat them up, which isn't going to probably do much. It didn't do much. And I can discard a single tube. So if I wanted to discard the third tube, I select it, click on discard. It all goes into the waste bottle. If I want to throw away everything, I can discard all. It's going to ask me, do you really want to do that? I say, yep. And so they're all gone. So anyway, you guys ought to be getting an idea how to use this thing. So I'm going to go back now and stop sharing my screen and ask one more time. Does anybody got a question about anything? Okay. No. Oh, yeah. No, we're going to do one more. Since we're not doing a research project, we're going to do one more lab, because in the fall when I had the class, we were doing one more lab. And then when I was planning for this semester, I took a lab out and was going to replace it with a research project. But I can't figure out how we can do a research project. So we'll just do one more lab. Okay. Okay, I got a couple more people I need to put into groups, and then we can get going here. We're not going to do lecture tonight. You guys are still ahead of the other section, so we'll just leave it like that, and we'll just do lecture on Thursday. Okay, I think I got everybody put in a group. So, oh, do I still have something going here? Oh, when's our next exam? I don't know. I don't know if there's going to be a next exam. I'll certainly, I think we got 3 weeks left until finals week. I would definitely give you a week advance warning if we're going to do another one. But right now, it's not looking like there'll be one. Okay, so I'm going to start up your groups. If you see that I've put you in the wrong group, please send me a chat. I'll move you to the right group. And if you have a question about how to do the experiment, send me a chat and I'll answer your question. So, okay. Yep, everybody's in their group. I'm going to start those. Oh, wait a minute. Will the percentage of the final stay the same? Yeah, the way things will be is right now the percentages are based on 100% total. But if we don't do something, then it'll be based on some other total percent. So if we don't do a fourth exam, I believe it was worth, it's either 16 or 18%, I don't remember for sure. Then that means that, let's see, if it was 18%, then that would be 82, yeah, it'd be based on 82% would be the maximum. And if, you know, does that mean our grades would go up or down? Let me think. I don't think it should make them go either way, actually. Like right now, if we did not do a final, if we didn't do anything else that got a grade, then your grade would be whatever it's saying in Blackboard. So then, you know, your lab report here, hopefully everybody will get that and won't be a problem there. We've got some homework coming up. But let's just assume that our averages for our homeworks and our topic introductions and our lab report stays the same. Then the only, if we don't have a exam 4, the only thing we have left is the final. And if you do, basically if you do the same on the final this now as it would have before, let's see, would it be worth any more? I have to think about that. Yeah, I guess it would be worth a little bit more because instead of being out of 100%, it would be out of 82. It wouldn't be a huge change. But anyway, I haven't actually said for sure we're not going to do a fourth exam. We may still do a fourth exam, in which case everything will just be the way it was before. Okay, am I